All right, now for topic 3, now we're going to solve the polynomial equation. You might need to refer to these notes where we have to set the equation equal to 0, factor, and then set each factor equal to 0 to solve for x. So you can look at these notes to help you, guide you on some of the problems on our review packet. Now, on our first two set of problems here, because we already have it in factor form with these parentheses here, all I have to do is set each factor. Each one of these is a factor. The x is a factor, so you're going to set that equal to 0. Then I'm just going to do like a t-chart. Oops, sorry. Then our next grouping here, we're going to set that equal to 0. X minus 8 is going to equal to 0. And then the other factor we have is x plus 2 equal to 0. Now, I know you can do some of these mentally. Well, x equals 0, that's one of our solutions right there. Here, when I'm setting this factor equal to 0 to solve, I would do plus 8. So I know some of you, because you recognize that there's no coefficient here, and you know that if you have a binomial, the solution is opposite of the operation here. So if it's minus 8, then our solution here is going to be negative 8. So there's one of our solutions. And so this one here, you can either show it by subtracting 2 from both sides, and we get x equals negative 2. Okay, so if it's already in factor form, which this is an example of, this is factor form, you can set each factor, which means the GCF that we have outside the parentheses, 2x squared equal to 0, and then this binomial, x squared minus 25 equal to 0. So you can, this one I can solve because I have no coefficient here, or I can recognize that this is a difference of squares. Okay, difference. I'm just going to write it up here because this is a perfect square and that's a perfect square. So when I simplify this, this turns into, and I'm going to just write it underneath here, guys. If I do difference of squares here, this would be this will turn into, sorry, I got rid of my pen, x minus 5 and x plus 5, and you would have each binomial here equal to 0. So this would actually turn into x equals a positive and a negative 5. And then here, well, even if I did the algebra divided by 2, x squared equals 0, well, x equals just 0. Okay, so oops, sorry about that. So if it's in factor form, just set each factor equal to 0. It's not until we get to the next page here. Sorry. Now we have to set it equal to 0. See, this is equal to 64x. So we're going to have to subtract the 64x on both sides. We get 25x to the third power minus 64x equals 0. Now it's equal to 0. And then I'm always checking for GCF, which they do. It is x here. So this will simplify to 25x squared minus 8. Make that equal to 0. And then when I look here, this is a difference of squares. So I can simplify that further. Keep the GCF. Take the square roots of each term. So this is 5x minus 8. And, sorry, 5x plus, I forgot my x, sorry. 5x plus 8 equal to 0. So each term is going to be equal to 0. All right, we're going to need to solve for each binomial here. Basically, you're going to solve for x here. To do that, you're going to add the 8 on both sides. I'm only going to do this first one because I noticed they're both the same. So I just wanted you to see that this will end up being the same answer. You're going to divide by the coefficient of 5. So our answer is one's going to be a positive 8 and one's going to be a negative. So to show that, you do plus minus 8 over 5. So our two solutions are x equals 0. That was this first factor here. And then, let me fix this, make this better. Right. X equals 0, this one. Dang it, sorry guys. That was this first factor. Get my pen to work right. And then x equals a plus minus -5. So that was from these two factors that were the same. Just one's positive, one's negative. Okay. Now on 21 here, it's already equal to 0, but hopefully you instantly recognize you're going to have to factor by grouping. Okay. Take out the GCF of each group. This one would be the x squared. Okay. So x squared parentheses 4x plus 5. Then the GCF for the next group would be 4. So minus 4. This would be 4x minus 5 as well. We got the common binomial, which is what we need. That is one of our factors. Sorry. 4x minus 5. And then the other factors are the GCFs here, which is x squared minus 4. And again, this is a difference of squares. So I can break this polynomial, this binomial, down further, which you need to do. So the 4x plus 5 stays, but now we're writing x minus 2 and x plus 2. Each one of these factors is going to equal to 0 here. Well, when I'm solving this first binomial, I would have to subtract 5 on both sides. So I'm just doing this mentally. When I do that, that's going to give 4x equals -5 and divide by 4. So x equals a -5 over 4. This is a fraction answer. And then here we got one's negative, one's positive. So x is actually a plus or minus 2. I can do this one because there's no coefficient, no number in front of x. Like over here, there's a number in front of x that's 4. That's why you're going to end up dividing by the 4. If there's no number there, it's like an invisible 1. And so we're left with just that constant. So, oops, sorry, I don't know why it keeps doing that. So that are solutions for 21. Oh, if we can go back to that number. Now, for 23 here, it's not equal to 0. So you're going to first start off by adding 3 to both sides of the equation. This turns the equation to 6x squared minus 13x plus 6 equals 0. All right, now I have a coefficient, so we're going to do slide, multiply, and divide. So I'm doing 6 times the 6, that's going to give me 36. And I want factors of 36 with the sum of our b, which is -13. Well, that turns out to be a -9 and a -4. So I'm writing x minus 9 and x minus 4 equals 0, but because we slide over the 6, we have to divide by that 6. And these are going to get reduced. Now, I'm not going to put this in factor form. I just want to reduce each of these fractions here. Why does it keep doing that? I'm sorry, guys. So this can be reduced by, hold on.